Hi, this is Snow. Now I'm going to implement a queue with 2stacks. Okay, so we have two empty stacks. We can call them S1 and S2. And we're going to implement a queue. So for this, we're going to just implement the enqueue function and dequeue function. That means that the enqueue is to, then for example, this is a queue, and enqueue is to add an element to it, and to dequeue is to remove the element from the head of the queue. This is a real. Okay. So, as a user, the user don't know we are implementing a queue with stacks or array or linked list. They will just use the enqueue and dequeue function. So when they do enqueue, they want to add an element. When they do dequeue, they just want to get the first element in the queue. So for example, if for 1, 2, 3, 4, 5, we want to enqueue 1, 2, 3, 4, 5, and when we want to dequeue, what we expect to get is 1. And the second time we dequeue, it will be 2. So dequeue will return an element. And enqueue just add something to the queue. We don't need to return anything. Okay, so how to implement with 2stacks? So for stack 1, let's just try to put in the queue the 1, 2, 3, 4, 5. So we put in, it goes to the bottom, and then upper 1, 2, 3, 4, 5. So when we want to remove something, the 5 will be popped out. But what we want is the 1 to pop out. So since 1 is blocked by all the upper numbers, we should pop out those upper numbers to reach 1. So we can put them here. So 5 goes in, and then 4, and then 3, and then 2, then 1. So now we can just pop this 1 using a stacks pop function. And after we pop 1, if we want to dequeue again, what we expect to get is the 2. And 2 is right here, so we can continue to pop the next item in stack 2, right? And then what we want to, if we want to dequeue again, then we expect a 3, and then we can just pop this 3 until, if we want to dequeue all the way until the queue is empty, then we can just pop all the way until the stack is empty. So what if the user want to enqueue something again. So now that this S1 is empty, all of things goes to S2, and S2 is also empty because we have popped everything because we wanted to dequeue everything. And now if the user want to add another thing, so should we can, as usual, just add it to the stack 1. And then maybe add something else. And then we, for example, there's 3 more numbers. And okay, maybe not yet. So now let's do, now the user wants a DQ. So he wants to get the 6, right? So again, we put the we pop 7 and push it into stack 2, and we pop 6 until the S1 is empty, right? So we pop until S1 is empty, and then we pop the first item in S2, and then 6 is out. And now if the user wants to enqueue again, and we put 8 into this again. Oh, by the way, these are already in S2 now, so these are empty. So we have an 8 here. And now the user wants to dequeue again. And to dequeue it, we use the S2, and now this is gone, so 7 is out. That's right. And the user wants to dequeue again, so this is already empty, so we need to push what's in the S1 into S2. If S2 is empty, we need to pop S1 and push to S2, and until S1 is empty. So we have 8 here. Now we are ready to dequeue again. So let's conclude this method. So first we want to check whether the S1 and S2 has something. If both of them have nothing, then for DQ we cannot return anything. For NQ we can just put in anything. And yeah, NQ is really simple. It's just push something into the stack, and it should take a O of 1 time. And for DQ, we need to check whether S2 has something. If not, then we put everything from S1 into S2, and then we pop the top of S2. And if S2 is not empty, then we just pop the top of S2. Yeah, so we need to pop the top S2. Okay, now let's write some code. Oh, by the way, the time complexity of the DQ is amortized. It's amortized. The complexity is O of 1 because we don't do the because we not every time we put the whole array from S1 to S2. So usually, once we have put, for example, we have 1, 2, 3, 4, 5, 6, 7, 8 in our array, then once we have them in the S1, when we DQ, we put everything in the S1 to S2, and this takes O of n time because the length of the whole array. But after that, if we want to DQ, the time complexity would be O of 1 because we just pop the top of S2. So the average time complexity, for example, we DQ 8 times, and the first time the DQ takes O of n time, so O of 8 time, and the second to the 7th time we just use O of 1 time. So if the array is huge, then the average time for this DQ function would be, just O of 1. It's not O of n, right? So, the amortized complexity is O of 1, but the worst case time complexity is O of n. For example, you want to put everything in and then you just DQ once. So for that one time, the time complexity is O of 1, O of n. Okay, so now let's go type the code. Oh, I forgot something. For the time complexity, for example, if you want to add 9 here, and then to DQ, you just put 9 here, and if all the rest is empty, you just put 9 here and then pop it. So the total time complexity, like for once, you have to go the full array, but then if you DQ and NQ and DQ and NQ, then every time you just move a little bit of numbers from S1 to S2, then pop it. So just put those a little bit number is definitely not O of n. So the amortized complexity is O of 1. Okay, def. Not def. So we want to implement a queue. So it should be a class. Has 2stacks. DQ NQ this NQ. We need something to put in. So since it does, for NQ we just put into S1. So to put into S1, put something at the end of a array or stack is append S1. EQ. EQ. So first, if the two stacks are both empty, we cannot pop out anything. So if S sub S1 and sub S1 empty, so not S1 and S2, we can bring this to and return nothing, just end this function. And if not, so S1 or S2 should have something. So if it is F1 has something and S2 is empty, else if self S2 is empty, so if not self.S2, then we want to put everything in S1 into S2. So we want to pop self.S1.pop. What we popped will be pushed into S2. So S2 append what's popped out. And we need to do this until S1 is empty. So in a loop. Well, S1 has something. We append this. And after this while loop, the S1 will be empty. And so if S1 is empty, then we just S2 has something now. So S2 isn't, if S2 is not empty, so that means if S2 is empty, we put everything from S1 to S2, and now we can just DQ now. So then S2 that pop and this is what we want to return. Let me clean this up. Okay, so then write something here. That means S2. If not S2, so S2 is empty. But if S2 is not empty, then we just pop, right? So else else just means S2 is not empty and S1 is empty. And in that case, we just do the same thing, return what's popped out from S2, right? So we can come, this is a repetition of this line, so we can just remove this line here and delete this. So if S2 is empty, then we do this, but after we do this, F2 is not empty anymore. And if S2 is not empty, whether and S1 is now empty anyway, and we just do this. Okay, that's it.